Today we will talk about polynomial function. What is really a polynomial function? Does this involve graphs? How to solve it? Let's find it out. Please listen well. A polynomial function of degree n is a function of the form p of x is equals to a sub n x to the n power added to a sub n minus 1 x to the n minus 1 power and so on up to a sub 1 x added to a sub 0, where n is a non-negative integer. A sub n is not equals to 0 to number a sub 0, a sub 1, a sub 2 up to a sub n are called the coefficients of the polynomial. The number a sub 0 is the constant coefficient or constant term. The number a sub n, the coefficient of the highest power, is the leading coefficient, and the term a sub n x to the n power is the leading term. Graphs of polynomials. The first feature is that the graph of a polynomial function is continuous. Essentially, this means that the graph of a polynomial function has no breaks, holes, or gaps as shown in the figure A. The graph shown in figure B is an example of a piecewise defined function that is not continuous. The second feature is that the graph of a polynomial function has only smooth, rounded turns as shown in the figure 2.11. For instance, the function give f of x is equals to x, which has a sharp turn at the point 0 and 0 as shown in the figure 2.12, is not a polynomial function. Monomials. The simplest polynomial functions are the monomials. P of x is equal to xn, whose graphs are shown in the figure below. We have y is equal to x, y is equal to x squared, y is equal to x cubed, and y is equal to x to the fourth power. There are guidelines for graphing polynomial functions. First, the zeros. Factor the polynomial to find all its real zeros. These are the x-intercepts of the graph. Second, the test points. Make a table of values for the polynomial. Include test points to determine whether the graph of the polynomial lies above or below the x-axis on the intervals determined by zeros. Include the y-intercept in the table. Third, end behavior. Determine the end behavior of the polynomial. Lastly, graph. Plot the intercepts and the other points you found in the table. Sketch out a smooth curve that passes through these points and exhibits the required end behavior. Let's have an example. Number 1. P of x is equals to negative x cubed. The solution for that problem is that the graph of P of x is equals to negative x cubed is the reflection of the graph of y equals to x cubed in the x-axis. The next example is q of x is equals to x minus 2 multiplied by 4. The solution for that problem is that the graph of q of x is equals to x minus 2 multiplied by 4 is the graph of y is equals to x to the fourth power shifted to the right 2 units. A graph is shown below. Thank you for listening. We hope that you did well and you did learn something new.